All right, so let's take a look at this one. It says an experimental population of fruit flies increases according to the law of exponential growth. So as soon as I see that, exponential growth means that I am able to use this as my super general solution. There were 100 flies after the second day of the experiment. So that means, maybe if I can pull out some information, when t equals 2, y equals 100. And 300 flies after the fourth day. So when t equals 4, y equals 300. And the question is approximately how many flies were there in the original population. So basically, what is y when t equals 0 at the start? Okay, so that's kind of where we're at. This is a little different because we're not going to be able to solve for a, where a means the original population, because that's the question I'm asking. So we're going to look at a couple different strategies. Strategy 1 is to go ahead and basically write a system of equations. Okay, so I'm going to go ahead and plug in what I know. So 100 equals a e to the 2k. That's one of the equations I know from that first ordered pair of information. And the other one I know is 300 equals a e to the 4k. And so I'm going to do this two different ways. The first way is substitution. So I'm going to take this first equation and I'm going to get a alone. So in this first equation, a is the same thing as 100 divided by e to the 2k. And since the a has to be the same in both of these equations, what I'm going to do is I'm going to substitute it into the second one to eliminate that variable. So I'm going to have 300 equals 100 over e to the 2k times e to the 4k. Okay, and I might think about that as e to the 4k over 1. Well, certainly I can do a little bit of work here. You notice there is no a, so I should be able to kind of solve for k. So over here, I can actually simplify this part of it. When you are dividing like bases, you know that you can subtract the exponents. So I'm still going to have the 100, and then e to the 4k minus 2k is e to the 2k, which means when I divide both sides by 100, I get 3 equals e to the 2k. And this is a place that we know exactly how to solve this. So I can go ahead and do the natural log of 3 equals the natural log of e to the 2k, which would just be 2k. And so k equals natural log of 3 divided by 2. Once I have that, well, then I certainly can figure out what a is, because I know that a is related to that k value, right? And so once I have that, then I can say a equals 100 over e to the 2 times ln 3 over 2. My 2's are going to cancel. And so this is 100 over e to the natural log of 3. Well, e to the natural log of 3, those things are undoing of each other, and so e to the natural log of 3 is the same thing as just 3. So that's what my a value will be. Okay. So the initial population is the definition of a, right? That is the initial or starting amount. And so when t equals 0, there would be 100 over 3 flies, which I don't know about you, but kind of trips me out a little bit. I think then they would probably ask you to round to the nearest fly. Okay, so about 33 flies. In general, I would say on the AP test and elsewhere, I would make sure that I just round to AP rounding unless they tell me otherwise. So I still would have this as my final answer unless it said something about rounding it otherwise. All right, alternative strategy is to set up a system of exponential equations. In the past, you guys have done systems of linear equations where you added or subtracted them together to eliminate a variable. Instead, you can divide to eliminate a variable. So if I take the two equations that I already have, okay, and I divide them, it doesn't matter what order you divide them in, but I want to kind of make this nice, right? What you'll see is 300 divided by 100 is 3. A divided by a, that totally cancels out, right? And then again, I have this e to the 4k divided by e to the 2k, which means I can subtract those exponents because I'm dealing with like bases, and that should look really familiar, right? We actually already got to that point. It's just with a little bit less work. Okay, and then you would just continue to solve it like that. And so that's a strategy that if you have exponential equations, sometimes I think it's helpful to just divide them because it gets to your answer quicker. If that doesn't make sense to you, certainly substitution will work instead.